Yeah. In this video, I'm going to tell you a little bit about Isaac Newton's theory on gravity and F equals mass acceleration. After that, it's going to be short. After that, I'm going to tell you about relativity and E equals mc squared, about some things you didn't know about that equation and the theory behind it for faster than light speed straight space travel, which means time travel. But that's up to you to believe and think what it's your opinion of the theory. I'm going to also introduce you to a new theory that has been developed that actually has the framework, the paperwork, the analogy, and the equations to show that faster than light speed space travel is possible. And more. Not just light speed, even faster than that. Shortly, I'll be getting into this explanation. So hold on. Thank you. Yeah, getting into the technology between about Isaac Newton's theory on F equals mass acceleration. First of all, I want to tell you that F equals ma is a collective. It's a bundled equation. It means different things in different categories. Gravity, is first, second, and third laws. The third law of universal gravity means you take gravity out of the equation and you have an absolute velocity. So if you can go 50 miles an hour in a ship in space, then without gravity, because that's what the third law tells us, then you're going to go 50,000 miles an hour. But with gravity, F, the same as Einstein's E equals mc squared, or mc1, or mc2, whatever you want to use, it's the same thing. It's he just inverted E for F. E is the equation of energy. But what he did, in addition to that, he enabled us to, or he created an equation in which we can measure that energy in mass. Mass was around even with Isaac Newton. They called it mass, but their perception of that mass was matter. When E equals mc squared came out, he converted that to energy. This energy is the means of how gravity works. So if you want to talk about gravity, you can talk about E, because that's what E is. It's an invisible force that exists on matter, planetary planets. Isaac also was able to measure the distance between two objects or in space, two planets, relative to their size and mass. If you have one planet that is 1/3 of another planet, and you want to know how close they are, you divide it by 1/3, because that's what the smallest one entails, and that's how far. You're 2/3 the distance of the size of that planet. So we have bundled equations, mass acceleration, Same thing in Isaac Newton's as in Albert Einstein's theory in relativity. E takes takes away the letter F, and you have mass. And then instead of acceleration, Albert Einstein put a C there relative to energy, of which he measures by the speed of light. Now, the speed of light is energy without any implications to any mass. It does have mass. Things that don't have mass, you can't, they're invisible. So light as a radiation has a mass. What that mass is, it's very small, considerably small. But you see where I'm coming from. Gravity is invisible, yet it's we can measure it, or we can manifest and visualize its effect on other things. Now, the new theory of which I'm going to have conflict with these two theories. One is the mass relative to the gravity that exists in a confined compartment or environment like Earth's atmosphere. It's Earth's atmosphere. It's the Earth that creates all the interferences that exist. When you go into space, there's only one interference, and that's the vacuum and the vacuum pressure. So we have another equation called P equals ma or mc. But in the new theory, which you'll be hearing a little bit more and more about, P equals, or E of P equals m, the mass. And if you look at all of Einstein's equation, the mass is 0. So you could go back and take Isaac Newton says the mass is such, but you can't measure it because they believe that it was just a chunk of matter. But still, you have to know the size of that matter to implicate it into Einstein's theory, which I don't think he does. It's just his equations emulate the idea that it's mass is mass because of its energy, which is the speed of light. But that kind of varies when you look at a marble, round marble, and you get the little ones, you get the little bigger, it's like a quarter, looking at a dime and a quarter, they have different sizes. So they have more potential masses than others. But anyways, that's relativity. And that is a bundled equation. It was taken out of the contents of Isaac Newton's ideas. His observations are formulated in relativity, things that he couldn't figure out at the time when he was reinventing his telescopes, the ability to see the stars and planets and see the actions on these planets. It was a primitive time. Einstein came along, another 100 years later, because now it's another 100, So mainly history works in hundreds of years. But anyways, so E equals mc squared is a bundled equation. It has various meanings to various activities in modern physics. On this new theory, which is called the quantum physics theory, there's quite a few videos on it. Some of the latest are the latest new discoveries about motion, about P equals mc or ma. And the reason that there's a difference there is because 5 years after Einstein had already published his work, which is everything veritable to see, they found out the universe was expanding. So C is taken out of the equation again, but nobody has ever done that. And yet. And it hasn't been replaced, but the idea that an expanding universe, something that is moving, is not critical to an absolute speed of light content. But nobody has, I believe, and in the new theory, C is replaced with G. So wherever you're at on any planet, G is the new equation to measure from F equals mg or E equals mg of that planet, whether it's a small planet, a large planet, and how much gravity exists. Because C was gravity, the speed of light. That's what relativity tells us. C is the speed of light. Or G, excuse me. G is the speed of light, but C is the speed of light. You know, you kind of know what I'm saying, I hope. But anyways, I've been studying these theories in the last 20, 25 years as an option to other things, you know, that I'm interested in, you know. And I've conformed the idea that if you take Newton's theory and Einstein's, you can convert each equation differently. E is F, F is P, and that's in the books. And C is MA or whatever you want to do. That's in the book. That's why it's called a bundled equation. You'll never know it all. But if you know certain specifics in these equations, like what I'm talking about, they are bundled equations. Well, in this new theory, we'll be talking about things a little bit differently. And the concept, this video is just on velocity, the speed of light, its origin, and why the speed of light seems to be so important. So keep up. I'll be right back. Okay, here I am. I'm back. Now I'm going to tell you about a new theory that you don't know about because it's not in the archives. It's not in the archives like Albert Einstein became a household name that everybody knew, and Isaac Newton, because history tells us in educational curriculum, you know, like in school and college and all these things, that it is not a household name, but it is a known name. So what I'll be telling you about now is called the quantum physics theory. What is the quantum physics theory? It's a vision. It's a vision to reinvent by researching past important theories that have to do with space travel. As such, it goes into Isaac Newton's theories, it goes into Albert Einstein's, Edwin Hubble's expanding universe theory, and then it lays on another quality or quantity about space travel, and that's space expansion. So what is space expansion? Space expansion is almost the same thing as universe expansion. But we're not talking about the galaxies and the universe relative to those galaxies as expanding. We're talking about the cause of that expansion, the Hubble expansion, which is space. Something is making space multiply in itself and creating more space that is pushing the galaxies away from each other. Now, in Einstein's theory, relativity, he explains this as a conflict between matter, planetary matter, and the galaxies, all matter, and space itself, or Dirk's C. When you look at Dirk's C, we're talking about everything is made up of some kind of particle. That's what Dirk's C is. And all the particles that exist in matter, which are the planets and everything, all that matter, even in us, they are made up of particles, so space is made up of particles. And planets are made up of particles. And the forces that are contained by these particles in the different situations that they are. And gravity is one of these situations. Now, Edwin Hubble came along in 1925 and found out the universe was expanding. Something was going on. His illustration tells us it's like a balloon that is being constantly blown up. And because of this, the planets, or the galaxies, not the planets and stars, the galaxies are being spread apart. And c, the speed of light, as Einstein explains it, is counterplayed by it's not constant no more because something's happened in the universe. The galaxies are spreading apart. So Edwin Hubble explained it as a balloon blowing up. And he shows dots on that balloon, and as this anomaly expands, it spans the space between the galaxies, space itself. That's one cause. The other illustration to this is a man-made lake. You dig a hole, but you got to put water in it to make it a lake. And so you take a big old hose, and you throw it in there at the bottom, and you keep filling it up. More and water is coming from someplace else. But it's creating this lake. And gradually the lake fills up the hole. And that's what Einstein thought about the universe and space. It's filled up. It's at the speed of light. Nothing can travel faster than the speed of light. Edwin Hubble's theory tells us that the hole is still getting filled up. And that's universe expansion. Space expansion is the water that is continually duplicating itself and creating more space that is filling between the galaxies. Then we can go into a more common theory called the cosmic background image. And the cosmic background image is an image of what they believe the universe looks like. And it's an image. It's a round, oval image. The same thing as what Edwin Hubble said the universe looked like as a balloon, but it's inflating. It's getting bigger, creating more mass, let's say. And that's the difference between the cosmic background, imagery, and Edwin Hubble's theory. And the third is the water in the man-made lake. The lady in the lake. But anyways, this is the foundation of the quantum physics theory. Taking all this into consideration and changing F or E equals MA or MC into MG, big G, little g. And I'm not going to talk about it in this video, but there's a conflict of the big G and the little g. This is interesting. It's mentioned in some of my other videos, but it's not like this, an explanation in this video. So what is the quantum physics theory? It takes the general classical and modern physics formulas and reinvents them into a state of where there's no real time travel, because Einstein's theory, which is modern physics, tells us if you exceed the light, like Edwin Hubble's theory tells us we are exceeding in the universe, you time travel. So in other words, if we can travel faster than light, we don't time travel. We just travel. And efforts has been in the entertainment business is showing this. Space-time. We convert. We're on Earth, and Earth is, we're slow moving. You know, we're life on a planet, and we're confined to this environment of the planet, and we are slow. When you go into space, we're talking about seconds. Things can happen in seconds, literally. You go into Isaac Newton's theory, universal gravity, where absolute velocity is absolute velocity. You go 50 miles an hour in space, no gravity, and you're going to go 50 miles an hour. So you take that, Einstein put a C on that, says if you go the speed of light, you can go travel at the speed of light. Yeah. But C is changed again. In Edwin Hubble's theory, you can, the galaxies are traveling away from each other at a velocity that's greater than light. And there's a whole new formula for that. And I don't claim to have them all, but I got a lot of them. A lot of them. And the G taking the place of C is one of them. Rather than looking at the universe all the same way, we have independent changes that exist to the different planets that we plan to explore. It seems to be Earth's and mankind's directive to journey to the stars. But anyways, I've written I did a couple short videos on YouTube, twice light speed. Conformably doesn't actually stop there. We can go greater velocities once we take C out of the equation. But what's going to replace that? Now, in all my diggings, I went all the way down to the propulsion, which is a different P equals MA or MC or MG, called propulsion and not pressure. Now, mind it, Einstein did not create that equation. He just put E in the place. He formulated energy as the mass that in 1667 was not recognized. Okay, so we go back, and we, instead of using pressure, we're going to change that to propulsion. Now, propulsion relative to E equals mc or F. Change F to P for propulsion. mg, which is gravity, to make it, to simplify it from all the other planets that exist. And we're weighing all this on Earth's measurements, the measurements that we get on Earth, not some other planet. So when we hit another planet, they might be smaller or they might be larger. But, so we have a propulsion value. Now, what I told you about bundled equations, F equals Isaac Newton, F equals ma, mass acceleration, or Albert Einstein's theory of E equals mass at the speed of light. These are bundled equations. They explain many things. Okay. Now with G, like I says, we conform to Earth's environment. Those are our numbers. Those are our equations that we use, and they may be different on other planets, but that's the ones we use. Earth. So we have propulsion. What, as a bundled number, a bundled equation in Isaac Newton's theory, Einstein's theory, and relative to Edwin, the expanding universe theory, P is not E, but is propulsion. And propulsion relative to G, whichever G it is different than E, because we're talking about propulsion. Now, relativity just says, well, you can't go fast as the speed of light because of E, you know. And on Earth, if you try to go the fast of light, you're only going to go half the speed of light, which changes E to 1/2 E equals mc, which is the energy content of all matter, but it has nothing to do with space travel. I mean, it has to do with light. It's my idea. And this has to be changed. Edwin Hubble didn't go into space adventure journeys in his theory. Einstein had the rockets, and Edwin Hubble had the planets and the galaxies. But anyways, so we have propulsion. But as bundled numbers, like in Newton and Einstein, they mean other things. Now we go into propulsion, and as a bundled number, that's what it means. It means that if you have F or E and that much energy or propulsion, let's say, or force, and you apply it to M, which is 0, but not all the time. In space, it's 0. And in all Einstein's equation, you'll see it's a little 0. But on Earth, there's no 0. That occupies a space. And so we conform to G because it takes up that space. So we have P, propulsion, which is the same thing as the force. Relative to E, we got mass, and we have big G and little g. In the little g, which is Earth, we're confined to gravity. You push something and make it roll, and it's going to slow down because of gravity. It's not just going to keep going like Isaac Newton's universal gravity, the big G. But you take that same boulder, put it in space, and give it a push, and it's just going to keep going. There's nothing there to stop it. It's just going to keep going, and it's going to stay that way. for a long time, unless it falls into some gravity well where it falls into some planet or sun or something or some star. But imagining that this doesn't happen, please subscribe. Little g slows us down. Big G, the universe is expanding. So that big G conforms to a repulse force. Something that seems you can sit in it and stay there. But when you start to move, it's going to accelerate you. It's going to help you. It's going to keep going. Keep on going, dude. Keep on going. The same way as the little g on Earth slows you down in space, you're going to get speeded up. So we know about Earth's gravity. And we know those numbers. And we go into space and we have a vacuum that we call the big G, which is no gravity at all. That's what it means. Now you can conform to what people, this little gravity over here, we got some impulse, little particles running over here, they seem to pop in and out and all that stuff. But vaguely, those don't count. Now you go into relativity and Einstein talks about extreme. Extreme is invisible. Extreme forces will change all that, you know. Stuff he knew about. So anyways, we're in space and we conform to our velocity. But now we have to go down to propulsion and the engines and design it for those engines. How does that work? We know that bundled equations, F or E, bundled up equal M, C, M, A, acceleration, and you put more energy in it, it's going to go further. But that's kind of like one-sidedness when we talk about bundled like that. And I'm going to tell you why. We're talking about the quantum physics theory, and this is how it works. We know in space that if we accelerate to a velocity, we're going to travel at that velocity. On Earth, where we're making the ships, the engines for these ships, that we're gonna put them on a spaceship and take them out to the moon, where they're assembling a spaceship for them, for the engines. When we look at the blueprints for propulsion, we got bundled numbers because of Einstein. We got bundled numbers because of Newton. We got bundled Aristotle. We got bundled numbers. They can mean anything. You know, you got a ship. Well, it just puts more energy in it. You know, we go faster and stuff. Yeah, sure. You know, we go faster. But if you believe that in relativity that the speed of light is constant, and the reason the speed of light might be constant is because of relativity, you know, and it's confirmation with matter relative to relativity, G, general relativity. We got to go further and do the thinking of rethinking that. But let's go back to the velocity of P, which is propulsion, equals mg, big G. Now we're making these engines, and those engines have to have a formula. Well, we can use Einstein's E equals mc squared. We can use Newton's F equals ma and just keep adding energy, you know. But do we really want to do that? Now, without leaving anything out, Isaac Newton opened up an idea called dual acceleration. Well, instead of having one engine, we could have two engines. Then the force wouldn't be stronger in one engine. It would be because we have it in two engines. So if we want to travel at the speed of light, we use one engine till we hit half the speed of light, kick in the other engine that has more power, more energy, and we'll hit light speed, dude. No, it don't work that way. It don't work that way. Here's the mechanics. Quantum mechanics, light speed mechanics. When you have a car on Earth, right? And you get in it and you hit 60 miles an hour, let's say, right? Bam. And you can push on it and go 70, 80, you know. But you can't go 300 or 350. You could with a different engine, but not with the regular engine. But what people and what bundled equations do is raise the acceleration level of the force in the engine. And if the engine has the ability to travel 60 miles an hour, it's pushing out. Listen, it's pushing out 120 units of force, of E, of energy force, whatever you want, propulsion force, actually. But we only go 60 miles an hour. Why? Because of gravity. Right? Now, to understand what I'm talking about, you got E, which is 60 miles an hour. Then you got another, an extra in the engine, another 60 miles an hour of G that you ain't using because of gravity. Gravity slows you down. So we go back to the big G. We get in our spaceship from on the moon, and we say, we're going to go places, dude. So we put a couple engines on it, maybe 2 or 3 of them, right? And they conform, each one, the speed of light. All we have to do is take the equations of the 60 miles an hour, which is in relativity the speed of light, but you're going to only go half the speed of light, which is the 60 miles an hour. But you have energy for the speed of light. So we're conforming. We are creating a type of an equation or formula that we're following. So now we're in space on the moon, and we got a couple engines. Now these engines conform to the speed of light. If you go to the speed of light, you're going to travel at the speed of light, right? Right. There's none slows down, right? Right. But in the blueprints, what's not there is you need 2 pounds of energy, not 1 pound, not bundled in Isaac Newton or Albert Einstein's theory. Those are bundled equations. But you need 2 pounds of energy to push, to accelerate a 1 pound mass. Now, the object of this, we go into the big G, back in space, and our ship weighs almost 0. We're on the moon. I mean, almost 0. But we have 2 engines. We have each engine that can conform to, now this ain't real, but they're trying to make warp engines. See, this is the story, the result of the story. We have an engine that's going to travel at the speed of light, but that engine was made from Earth. technology. And the Earth technology, which isn't present today, but is now, is that to make our car go 60 miles an hour, we needed 120 miles an hour of force or energy to do that. So now we applied our energies to this equation. We don't bundle it up and say, oh, we just need more energy, we just need more force. No, our energies are, Einstein says you can't go faster than light. A lot of people believe that, but open up your mind a little bit here. Our engines that take us 60 miles an hour on Earth need 120 miles an hour of energy. So we have a ship that weighs almost nothing. And we have our engine that conforms to the speed of light, because that's how the equations work and that's how we made it. But it takes 2 pounds of energy. Now you could say, well then if it takes 2 pounds of energy, the ship weighs 0 now. You don't need that exactly. You don't need it. Because the weight is not an effect of the acceleration in space. So all you need is the capacity to travel light speed. The same as general relativity tells us. We can only get close to it. Okay, close to it. And that's our engine. But in space, mass is expelled from the equation, even though we built the engines relative to twice as much energy. So, what happens? We eliminate G, which makes it a big G. We have no forces slowing us down. And we put our gas on the pedal. Now, Einstein, you can only go half that. 12 hours. No, you go all of it. And as you go all of it, because we conformed our equations and formula to twice as much energy, of which relativity says you can't do that. You can't make the engines do twice light speed. Is still only going to go speed of light. You make your own opinion about that. So we conformed our technology to say, put twice as much, not bundle it up and add some, Put twice as much energy in that engine. Make it correlate and spin faster. Make it greater force. And guess what? It's going to go twice light speed. It's going to go. But right now, we're dealing with bundled equations. And I'll tell you another thing about bundled equations. Bundled equations are a lot of your videos that you see on YouTube. You're trying to explain the speed of light according to Einstein. I'm not saying Einstein's wrong. I'm saying that was 100 years ago. I think we got a lot more. We have jumped. We got internet, dude. 30 years ago, whenever it was made, dude, well, they got satellites full of empty information that we correlate to. We got phones that we put in our pocket. What's up? We got satellites that we get information all the way from Mars. What's up? We need to go faster. And this is how it's going to be done, or should be analyzed for approval, or whatever you want to call it. This is the quantum physics theory. And again, when you take all those provisions away or out of E equals MC squared, well, you can't do that because you got this, and you can't, because you got this, you can't do that, you know. It's like having a circuit board that you break off a corner and it cuts it all out, where our technology in space can't use that kind of equipment, that kind of circuit board or circuitry. Not only does it have a backup, it has have a backup with a backup and probably another backup with that. And when you break the corner off, it automatically changes paths, works the same way, but uses a different pathway, opens up a different pathway. Even though you have two pathways that where you broke it isn't open, the other one isn't open until you break the other one. So you have a big explosion in space, but guess what? Your circuit board still works. Anyways, I thought I'd throw that in. Anyways, I hope you like my video. My name is Rod Kowicki. Thank you. That's all, folks.